Right, so this is the second lesson in the representation of data stuff, and what we're talking about today is we're talking about binary and how it works with a computer. Now, binary is really important when we're talking about computers. A computer can only process instructions in something called machine code. Machine code is basically ones and zeros. 1 0 1 1 1 1 0 1 1 1. And it can only process that in these. This means that all other languages have to be translated into machine code. So even if you're programming in high-level languages, so high-level language, it has to be translated from VB, which is obviously what we study in, down to a low-level language, which is known as assembly code. That's the spell. I'm just going to put assembly. And when it's gone through that, then it gets to machine code, which is ones and zeros. The high-level language is really easy to code, whereas machine code is hard to impossible. But if you wrote all your programs in machine code, it would be really fast. And that means, and of course, so there is the balance. So it goes from easy to hard, but it also has a speed efficient as well. So basically, the lower level you program in, the faster your code's going to go. Now, we've been talking about converting binary numbers. Okay, we've worked before where we've talked about how binary is represented by 1, 2, 4, 8, 16, 32, 64. And we can represent any number we want by putting zeros and ones in the spaces. And then what we do is we add up the ones and then it will come out with a number. So this number is 16 and 8 is 24, plus 2 equals 26. Okay? So now what we're talking about is something that's a little bit more advanced. And what we're going to talk about next is we're going to talk about binary mathematics. Now, binary mathematics is another way, is a way of adding up. And computers, you have to remember, only ever do mathematical operations. So when we're talking about binary mathematics, we're talking about doing this. Now, when we do a mathematical sum, what you have to do is you have to show you're working, just like we do in maths. So I'm just going to draw a line under this. So say if I was doing an exam question and I was told to add two numbers together, I'm just going to make these up. So if I was told to add 24 and 36 together, okay? Now I could do that very quickly in my head, okay? But I need to show binary mathematics. So the way you do this is you write out the numbers across the top of the page. And then what you do is you translate them. So 16 and 8 is 24, then put zeros in their rightful places. Then I need 36. So what I'll do is I'll do 36. So 32, 0, 0, and then 32, I need 36, so I need 4 more. There you go. So now I've got 24 here, and I've got 36 here. Now what I need to do is I need to add them together. Now, I know that you could probably add these together in your head. It would be wrong of me to suggest that you add these together and then work out the binary from it. But I will show you how to do it properly. So if you have a 0 and a 0, if I add nothing and nothing together, it's going to come out of nothing. If I add another nothing and nothing together, it's still going to come out of nothing. If I add nothing and 1 together, it's going to come out as 1. If I add 1 and nothing together, it's going to come out as 1. And if I add 1 and nothing together, 1, and 0 and 1 together is 1. So, and then 0. Now, if I work that out, so 32 and 16 is 48, plus 8, which will make 54, plus 4, which is going to make 58. Right? I think that's right. Now I can always check my marking. Actually, I'm wrong. You see, because 24 and 36, 4 and 6 is going to be 0. So I've added these up there. I must have made a mistake. So it's going to come out as 60. So I must have done my maths wrong. But at least then it's a way of double checking exactly how we add up. Now the really difficult bit is when we've got, say, I'm just going to manipulate this sum a little bit. I'm just going to erase that for a minute. And erase these. The really difficult bit is when we've got something like this. Now, when I add these two together, 0 and 0 is still 0, 0 and 0 is still 0, 0 and 1 is still 1, 1 and 1. Now what do I do here? Now normally that would make 2. But because we're working in binary, and binary can only use 0 and 1, we've got a problem. So what we're going to have to do is we're going to delete the 2. It's still going to be, it's going to turn out at 0, but we're going to carry the 1. And then we've got 1 and 1. Well, that's going to work out at 0, so I carry the 1. And then I've got 1 and 1, which is going to work at 0, and I'm still going to carry the 1. And then at the end, I've got 1. Now, if you add all them together, it should come out of the right answer, but it's very late here, and then my math's going to be right. So I've got 68 there. And here I've got 32 and 8, which is 40, so that makes 44. And 16 and 8 makes 24. And there you go. The maths works out. So at least it's showing you how to do binary and mathematics. Now the last bit I want to talk about is another number base. And another number base is hexadecimal. Now, hex is 6, because a hexagon is 6, and decimal, well, they're the numbers that we're used to, which is 10. So if we put it together, it equals 16. Now, computers can only represent one digit. So what happens is when we are working in hexadecimal, we tend to hit a problem because we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. What do I do now? Because I can only use one digit. So what it does is it uses letters of the alphabet. A, B, C, D, E, F. And that then represents 16. So it can be really, really difficult because suddenly we end up with numbers like, if I do 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 1, 0, 1. If I'm doing that, if I'm doing them, then I'm going to end up with FB3, 1. Now, what the heck is that to work out? So, hexadecimal is a different number base. And I'm going to stop there, but what I'm going to do is I'm going to carry on in the next lesson and explain how we convert between binary, which is 1s and 0s, to decimal, which is the one we all know, which is between 0 and 9, and hex, which is between 0 and 15, which is obviously the more difficult number base. And in the next lesson, that's what we're going to cover. But today what I want you to understand is hexadecimal and what that number base actually means, how to add together two numbers. If you did this in an exam, that will be worth 3 to 4 marks if you wrote it out in that way. And also how the computer uses binary. So basically how it's translated from your high-level languages like VB right the way down through assembly code into machine code, which is the bottom level, which is how languages are represented.